Okay, so for 3.2, we are going to solve systems algebraically. So there's two types. Normally, I will give you the option of whichever one you prefer, but sometimes one is preferred to the other, just the way that the two equations are written. So we have substitution, and then we have elimination. And at the top, it has notes for you, just in case you forget how to go about doing them. So if you get stuck on the homework, you can always refer back to the notes. But we're going to do some practice together. So the first two, number 1 and 2, we're going to do substitution, meaning I'm going to solve for one variable, and then I'm going to plug it in to the other equation. So in number 1, which one, the top or the bottom equation, is already solved for a variable? The bottom one. So this one is solved for x. So that means I'm going to take this 3 minus 3y, and I'm going to substitute it in for the x in the top equation. So I'm going to say that 2 times 3 minus 3y plus 5y equals negative 5. So all that I've done is I've substituted my x for 3 minus 3y. And the reason why I do that is so that I only have one variable or one letter that I'm dealing with, and then I can solve for that variable. So the next step is just solving. So I'm going to distribute and solve for y. So 6 minus y equals negative 5, negative y equals negative 11, y equals 11. So once you have y equals 11, you're going to take that and you're going to plug it back in to the substituted equation and solve for your x variable. So x equals 3 minus 3 times 11. So x equals 3 minus 33. So x equals negative 30. But I want your solution written as an ordered pair. So I will always be looking for ordered pairs as solutions. So my solution would be what? Negative 30, comma 11. Good. So I want to take this equation and then solve for x. But we're going to use substitution for 5 and 6. So number 5, I'm going to take the top one just by looking at it, and I'm going to solve for x. So x equals 2y plus 4. Then I'll plug it in for x here. But what do you notice happens to the y's? They end up canceling. So I get 12 equals 8. Does that even make any sense? No, it is a false statement. So when you get a statement that is false, you say that there is no solution, which is equivalent to having the same slope in different y-intercepts. So let's say, for instance, you just wanted to put both of these in slope-intercept form and solve for y, like y equals this, y equals that. You would find that they have the same slope, so they are parallel lines. They have the same slope but different y-intercepts. So that's why you end up getting, like, the y-intercept for the first line would be 12, the y-intercept for the second line would be 8. And then the slopes are the same, so that's why they end up canceling out. So if you get a false statement, then you would say that there's no solution. If we try number 6, that you can kind of predict what kind of solution we'll get here. So I'm going to take this one and solve for y, and then substitute for y up here. So what happens to the X's, they cancel, and I'm left with -9 equals -9. What do we notice about that? That is a true statement. So when your statement is true, that means they are the same line, so same slope, same y-intercept. And what does that tell you? How many solutions do we have? Infinite. So infinite solutions. Okay, so when we are doing elimination, that means you're wanting to cancel out one variable, either the x or the y. And that means that one of the signs needs to be positive and one needs to be negative. So number 7, they made pretty easy for us because what can I go ahead and cancel out? The 2y. So once you cancel, you have a positive and negative. It is like you are taking the top equation and then you're adding it to the bottom equation. So I'm going to add down. So I end up getting 7x, the y's cancel, equals 1 plus -8 is -7. So then I solve, and x equals -1. Once you have that, you can plug into either equation, either the top or the bottom. It does not matter. You'll end up getting the same answer. I normally just prefer the top, but sometimes the bottom one looks easier. So it is your preference. But let's say I'm just going to use the top. So 3 times -1 plus 2y equals 1. So -3 plus 2y equals 1. 2y equals 4. So y equals 2. So my answer in ordered pair would be what? -1, comma 2. If we look at number 8, so now it's not as easy. I'm gonna have to multiply one of the equations by a certain constant. And so just looking at these, do the x's or the y's look easier to cancel? X's, because they have a common factor. So I could turn the top one to be the x to be a -6x. And so what would I need to multiply this whole equation by in order to get that 3x to become a -6x? -2. -2. Draw the negative sign. There we go. So when I multiply the whole thing by -2, you have to do it to every term. So I get -6x plus 14y equals -20. And so now I am left with these two equations. The top one just kind of goes away because I've multiplied it. And now I'm going to add down. So the x's will cancel. I have a positive 6y and I have a -12. And so y equals -2. Now you can take this y equals -2 and plug it in. You could even plug it into the very top one if you wanted. I'll plug it into the top one just to show you. Yeah, you plug it into either original equation. Okay. So I'm going to take 3x minus 7 times -2 equals 10. So when you're plugging back in, you have 3 options now that I've multiplied. I have the top, the middle, and then the bottom one that I multiplied. Any of those would work. So 3x plus 14 equals 10. 3x equals -4. So x equals -4/3. If you get a fraction, that does not mean you did something wrong. So fractions are welcomed here. They are fine. Also, the thing that is going to get you on a test is not that you don't know how to do it. It's going to be these simple algebraic mistakes. So my advice to you when you take a quiz or test is check your work. Check, check, check. So my answer would be -4/3, comma, -2. Okay, I want you to try 9 and 10. Let's look at 11 and 12. We're not going to solve it. I'm not going to make you guys solve unless you want to for extra practice. But looking at 11, which one do you think would be the best to use? Substitution, because why? Yeah, because I've got this y equals, it's like already set up for me. It's nice. So I can just take the negative 4x minus 2 and plug it in for y up here. What about 12? What would I do? I would do elimination. No, we don't have to solve, or I'm not going to make you solve. I would do elimination, and I would probably eliminate which variable? The x, so I need to take this top one and multiply it by 2, and then I could cancel the 4. So just knowing which one to use is half the battle. Okay, so number 13, the graph is just there in case you prefer to graph. I haven't seen too many people that prefer to graph, but it is there if you need it. So like on the test and the quiz, I may provide graphs for you, but that doesn't mean that you need to feel like you have to use them. So a landscaping company placed 2 orders with a nursery. The first order was for 13 bushes and 4 trees and totaled $487. The second order was for 6 bushes and 2 trees, and it totaled $232. So I'm circling these numbers because there's a lot of words in there. And somehow you have to be able to read this paragraph and create 2 equations out of it. So that's why I circled the numbers, because I'm probably going to need those. And then the bills do not list the price per item, so I need to figure out what the price per item is. So what were the costs of 1 bush and 1 tree? Your first step in any type of word problem is identifying your variable. So that is step number 1. So I'm going to call x something and I'm going to call y something. So what am I trying to figure out? How much 1 bush and 1 tree costs. So I'm going to say that x is for bushes, so it's going to be the cost of 1 bush. And then I'm going to say that y is the cost of 1 tree. And so the second step, whenever you're doing this type of problem, is setting up your equations. So step number 2, I want to set up equations. So that is step number 2. So looking at that sentence, the first sentence, it says, the first order was 13 bushes and 4 trees, and the whole total was $487. So if I take 13 times the cost of 1 bush, so 13x, plus 4 times the cost of 1 tree, so 4y, that's going to equal $487. So if I were to create an equation for the second order, what would that look like? 6x plus 2y equals 232. Good. And now I need to solve either using substitution, elimination, or graphing. So step 3 is to solve. I normally like to use elimination, but it is up to you. So I'm going to use elimination. What would I need to do for elimination? What could I do? Good. By 2 or by negative 2? Negative 2. So I get negative 12x minus 4y equals negative 464. Then I'm going to add or combine with the first equation. So a positive 13 and negative 12 become a positive x. The y's will cancel. Equals, what is 487 minus 464? 23. Good. So that made life really easy. I didn't even have to do anything else. So when x equals 23, now I'm going to go in and plug that into an original. So I'll plug it into the top. So 13 times 23 plus 4y gives me 487. 13 times 23 is 299 plus 4y equals 487. Subtract 299 from each side. So 4y equals 188. So divide each side by 4. Y equals 47. Good. So my answer is, if it were an ordered pair, 23, 47. If I wanted to answer this question in the context of the problem, meaning like, what does that even mean, 23.47? Perfect. So that means that $23 per bush and 47 per tree. $47 per tree. So I want you to answer it as an ordered pair, and I want you to tell me what it means in the context of the problem. So you could see where the two equations are like this, and you're trying to find out the cost. Another example will be when they give you the total cost, and then they also give you the total number of people. So let's look at number 14. It says the admission fee for a small fair is $1.50 for children and $4 for adults. On a certain day, 2,200 people are at the fair and $5,050 is collected. So how many children and how many adults attended? So in this example, I'm not trying to figure out the cost. I'm trying to figure out the number of each type of person, children and adults. So I'm going to say I'm going to let X be the number of children. So it's not cost anymore, it's actual number. So number of children. And then I'm going to let Y be the number of adults. So out of the 2,200 people, how many of those are adults and how many are children? So when I create my equations, so step number 2, I'm going to have one equation that is total cost. And then I'm going to have the second equation is going to be the number of people. So if I created an equation for cost, what would that look like? So $1.50 times X, number of children, plus 4 times Y, because it's $4 for adults, equals, and the total fare collected $5,050. So that would be my cost equation. Then my number of people, how many people are at the fair? 2,200. So I'm going to say X plus Y equals 2,200. So that means if I add the number of children and the number of adults, they're going to add up to 2,200. So from there, I can do substitution or elimination. In this type of example, maybe I want to do substitution. But if you prefer elimination all the time, then do that. But I'm going to try both of them. So let's say X equals 2,200 minus Y. I'm going to plug that in. So 150 times 2,200 minus Y plus 4Y equals 5,050. I don't have my calculator with me. Can somebody tell me what 150 times 2,200 is? 3 what? 0, 0. Minus 1.5 Y plus 4Y. 50. Then I combine like terms. So plus 2.5 Y equals 50. Then I subtract 3,300 from each side. So 2.5 Y equals, what is 50 minus 3,300? 1,750. Divide by 2.5. I'm running out of room. Divide by 2.5 and you get Y equals what? 1,500. Or 700. Yeah. Because if you take 1,750 divided by 2.5, you get 700. Then I'm going to plug that in. Usually when you're plugging back in, it's easiest to use the bottom equation or the X plus Y because you don't have to multiply anything. So X plus 700 equals 2,200. And so X equals 2,200 minus 700, which becomes 1,500. So my answer as an ordered pair would be 1,500, 700. In the context of this problem, that would mean what? Great. So 1,500 children 700 adults. So number 17 is a different type of word problem, and it's using more mathy stuff, so you might even see geometry come back in a little bit. But things like complement, like what is a complementary angle? Like they add to 90. Supplementary, they add to 180, things like that. So you might have to dig a little further into your geometry brain, just a little bit, but not too much. Not too much, it's okay. So number 17, it says we have two numbers, x and y. Their sum is 5 and their difference is 1. And I realize that you could probably just guess and check your way to figure that out. But we're going to learn how a system of equations could work because they may not always be examples that are this easy. So sum means that you add, and then difference means that you subtract. So their sum is 5. So x plus y equals 5. And x minus y equals 1. So just looking at this, which one is an easy one to use out of substitution or elimination? Elimination, because which variable already cancels? Y. So 2x equals 6. So x equals 3. And so 3 plus y equals 5. So y equals 2. So my order pair would be 3, 2. This is where I said geometry comes in a little bit, but it's just using the word angle, so that shouldn't scare you too much. So we have two acute angles, x and y. Their sum is 87 degrees, and then their difference is 19. So I want you to try that one. Okay, so you should get 53 and 34. So 53 degrees, 34 degrees. Oh, that was the eraser. There we go. 53 degrees, 34 degrees. For number 19 and 20, I'm going to omit those because they require factoring, and I'm feeling generous today. So you won't have anything like those on the homework. So just cross through number 19 and 20.